Well, welcome everybody to the SC22 Student Cluster Competition Azure webinar. For those of you who attended this webinar last year, this is probably going to look pretty familiar with a few updates to include some of the rule changes and hardware that we've deployed since then. But with that, we'll go ahead and jump in. This is going to be kind of a short presentation and then followed up by a Q&A session. This is, kind of your guys' chance to ask questions. You can put the questions in chat, or when we get to the Q&A, feel free to come off mute, and I will pause a few times during the presentation to see if there's any questions there. We are recording, obviously, and this recording will be put on the webinars page as well, along with the slides. And then we will have follow-up conversations and announcements, both via the mailing list and on Discourse, with more details about the Azure component. So for those of you who don't know me, my name is Andy Howard. I'm a program manager on the Azure HPC and AI software and services team. I focus primarily on Cycle Cloud, but also kind of our HPC ecosystem all up in Azure. And Laura, if you want to introduce yourself.
Yeah, I'd love to. Thank you, Andy. So yeah, my name's Laura Parry. I sit within this weirdly titled team in Microsoft called the Global Black Belts. So I'm an HPC specialist. I'm based out of the UK, but our team has an EMEA-wide remit. But there is a global coverage of these GBB HPC specialists. So I'm going to be assisting Andy today. I'll be looking out for questions, comments, and then help move things along. So I'll pass back to you now, Andy.
Thanks, Laura. Yeah, Laura's here to help me keep my sanity this year. So essentially, rough agenda. First, we're going to go through kind of the overview of our approach and philosophy to HPC on Azure. It's kind of some marketing slides to start with. I'm going to buzz through those, and then we'll get into some of the hardware and software offerings that we have. And then at the end, we will talk about the testing window, competition budget, access to the testing environments and quotas for this year, and then open that up for Q&A. So let's go ahead and just dive in. So one of the cool things about HPC on Azure is that this is not just doing HPC in the cloud. We've kind of taken a different approach to some of the other public cloud providers in that we actually especially design our HPC offerings and services to run HPC workloads. So we're not just looking at what we already have and saying, well, can we fit HPC on this? Could we run certain workloads here? We're actually building purpose-built hardware, best-in-class interconnect, HPC storage, and then also the software that sits on top of that. Not only the software to deploy and manage those resources, but also tightly integrating with some of the more popular workflow managers and schedulers and software packages that are out there. And then on top of that, with the upcoming, quickly growing AI and machine learning space, trying to figure out how some of these other transformative services that we have fit in with HPC workflows. So it's a pretty exciting place to be. I put this slide back in only because I really like how much this keeps growing. Back in 2019, when we first announced the HB and HC series, which we'll talk about here in a minute, we were looking at 20,000 core MPI jobs. And now we're capable of running, MPI jobs that are well over 100,000 cores. Last year on the top 500 list at SC21, Azure landed a machine on the number 10 spot, which is kind of amazing in and of itself. But the fact that that's not just a cluster that we built to be a top 500 machine, it's an actual cluster that you can go and get time on and pay by the hour. And so that's pretty incredible to be able to enable that kind of access for people to that kind of that class of hardware. So essentially our goal is to be able to solve any HPC and AI workload at any scale, whether that's, I need a couple of nodes or even a couple of cores, all the way up to, like I said, being able to access 100,000 cores and GPUs and Lustre storage and all that sort of stuff. So everything from, the very simple B-series VMs, all the way up to specialty hardware such as H&N, which we'll talk about, even up to managed craze and Lustre. So we can do all of that. One of the other key things that differentiates our HPC cloud offerings is that we do actually have an InfiniBand network for all of our HPC VM types. And so as many of you probably know, having prepared for the competition, maybe you've gone through courses, but InfiniBand is really the leading HPC interconnect because it's super low latency, high bandwidth, and really helps for those parallel workloads.
Is
Is there a question? Maybe not. So let's dig in a little bit to some of the VM hardware that we have. First up is the H series. These are our CPU-based VMs with InfiniBand. We have both the HB and the HC. This slide's a little bit old. HB is not really targeted towards AMD HPC. It's more targeted towards memory bandwidth constrained workloads, and HC is targeted towards compute constrained workloads. So this is kind of back in 2019, we released the HB series and the HC, or the HB and HC VMs. These are fairly straightforward. HB is a 60-core VM, again, 200 gig InfiniBand, a lot of memory bandwidth there, and MPI scaling well over 80,000 cores. On the HC series, not much of a dense core count, so those are 44 core VMs. And again, not quite as much memory bandwidth, but you get quite a bit more compute power in each one of those. We did have an HPV2 that was a Rome-based AMD system. Last year, we released HPV3, which is our AMD Milan-based VM. And so they're kind of the same. HPV3 is just faster. It's the same pricing and everything. We'll get into one of the other big differences here in a minute. But yeah, these are, again, this slide is kind of a little bit old, but you can read here. So one of the other things that we did with HPV3, because the core counts on a lot of these VMs keeps going up and up and up, one of the questions that we had for customers was, well, what do I do for my workloads that I can't run on 120 cores on the VM? So you're giving me this whole machine and now I have to basically carve it up myself because maybe my job needs more than 3.7 gigs per core. Maybe it needs 14 gigs or my job uses 20 gigs. So what we've done is we do offer, I think we call them restricted sizes now. They're not a partial VM in the sense that you still, the full VM hardware is still allocated to you and your deployment. The difference is that we basically hold back a certain number of cores and only expose certain cores to you. The nice thing about us doing this versus you having to figure it out yourself is those cores that we choose to hold back are selected based on the Newman topology of the nodes. So that way you don't end up with a 16-core VM that's all hosted in just one single Newman domain. It's actually spread across the VM. So that's optimized for performance. This is just another kind of overview of the different offerings. Obviously, the slide hasn't been updated for HPV3. It's largely the same other than the teraflops and memory bandwidth. On the GPU side, I guess that title didn't come through quite right. We've got everything from visualization. We have a lot of customers who are looking to do their pre and post processing close to where their compute is. And so that's our NV series. We won't really get into that too much today. And then our NC and ND series are really targeted more towards compute and deep learning workloads. So everything from rendering to HPC simulation and deep learning and AI. The nice thing about the NC and ND series is they do support NVLink, and again, they have InfiniBand to help with keeping the GPUs loaded at all times. This is another slide that I really like, just kind of looking at how quickly our portfolio of GPU VMs has come out. This is one of the really attractive things and why customers tend to look to the cloud for their HPC workloads, particularly GPU-based ones. You know, as many of you are probably aware, NVIDIA and AMD love to just continuously release new hardware, and it's not very cheap. And so buying a cluster based off of a specific GPU, you may find that the next year it's already out of date. And there may be something that could give you tremendous performance gains that now you'd either have to find somebody to rebuy your hardware, which is particularly difficult with GPUs that have been used for compute, or essentially just stick with what you have. So this is, again, just kind of going over the different offerings we have. I'm happy to field any questions around, well, why would I choose this one over another? Typically as you move from NC over to the NC A100 V4, you're really just getting more and more power. Not all workloads may be able to take advantage of that, and so there are definitely, it is worth trying your workloads on some of these other, the earlier NC series, just to see if maybe it's good enough performance for what you need, because the price point's going to be significantly cheaper than an A100 VM with a bunch of InfiniBand cards hanging off the back. Again, this is down here, the overview of our NV series. This probably won't apply to any of you for the competition, although if teams are looking to do any visualization on Azure, please let me know. We can see about getting quota for that. And then we have our ND series, which is, they're designed for deep learning workloads. Now, what we are seeing is that more and more of our customers are actually using the ND series, not only for deep learning scenarios, but also traditional HPC workloads, just because these are pretty beefy boxes. The ND V4 and the NDM A100 V4 are essentially equivalent to NVIDIA's DGX series. And so in those, you have 8 A100 GPUs. And the really cool thing is you also get 8 200 gigabit per second InfiniBand cards. So each one of those has a total throughput of 1.6 terabits per second of connectivity between the nodes. And that is NVLink enabled. So you can really keep those GPUs fed at all times. And that's why we're seeing a lot more interest from people with extremely heavy duty HPC workloads that are GPU enabled. And then they also come with a significant amount of local memory and local disk space. So I'm going to pause there. Well, actually, yeah, this is just kind of covering the NDV4. I'll let you guys read through these slides. They will be posted up on the webinar site. Just wanted to include them. This is again, talking about the InfiniBand connectivity and then their placement on the actual node itself. So that it is all designed to be kind of as well balanced and well-rounded as it can be. So I'm going to go ahead and pause on the hardware stuff and see if there are any questions that people have around our hardware offerings, or any questions around what's going to be available for the competition. How do I choose what to use? Don't see any in chat. Feel free to come off mute if you want to ask a question there. All right. So all this hardware is really great, but you have to be able to actually run workloads on it. So as I said at the beginning, we do have some different services and software offerings that sit on top of that. Specific to HPC, we kind of have two major offerings, Azure Batch, which is our cloud native job scheduler. You can think of this kind of as more of the HPC as a service. All of those resources live in Azure. You submit your jobs to our job scheduler, or your tasks to our job scheduler, and we'll go out and spin up the resources and dispatch those tasks. Azure Cycle Cloud, which is going to be a lot more relevant to you because this is how you're going to be interacting with Azure through the competition, is it's a downloadable, installable product. You won't have to do that part for the competition. But what it allows you to do is deploy what we think of as traditional HPC clusters using traditional HPC job schedulers. So all of them that you're probably familiar with, from LSF to Slurm to PBS, Grid Engine, et cetera. And the other big benefit about using Cycle Cloud is that it does support both hybrid and cloud native workloads. So if you already have a Slurm cluster or an LSF cluster on-prem today, you can essentially point a partition or a host group to Azure and connect that with Cycle Cloud. And Cycle Cloud will handle anything that gets submitted to that partition or that queue and spin up the VMs in Azure and then run your jobs there. So the really nice thing about using Cycle Cloud is that for end users who are already used to working with traditional HPC job schedulers, for them, there's functionally no change in how they would interact with a cluster on Azure. It's the same job scheduler. You can customize the cluster's mount points and file system layout and the software stack that you're used to, and essentially use the same scripts that in some cases people have been running quite literally for decades. We have some customers that come to us with a script that was written back in the 80s and they want to run it on Azure. And this is a really easy way for them to kind of get onboarded without having to do a heavy lift and shift. So again, I'm not going to read through this slide. It's really just highlighting the benefits of using Cycle Cloud. These are the majority of the job schedulers that we support out of the box. The other nice thing about Cycle Cloud is that we do have customers who have written their own job schedulers, or ISV partners who've written their own job schedulers. And we do support enabling those schedulers to work with Cycle Cloud as well. So you get all the benefits of scalability and cost controls or cost reporting and monitoring that you would get with many of these job schedulers as well. Any questions about Cycle Cloud? We'll probably do another short webinar, or maybe I'll just link to the one we did last year. Honestly, most of that is still relevant today. That might be an easier way for people to just view that at their own leisure, and then we can take questions in discourse.
So I haven't seen any questions being raised in the chat yet, but don't be shy. Feel free to drop some in if you do have anything.
All right, I suspect this next section is probably what a lot of people joined for.
Yeah.
Talking about the actual access we're going to get for the competition, talking about budgets and rules and that sort of thing. Oh, there's a question in chat now. Do the resources for Cycle Cloud need to be pre-allocated? No, they don't need to be pre-allocated. They're actually allocated as jobs land on the job queue. Cycle Cloud, it depends a little bit on the scheduler, the exact mechanics for how it works. But essentially, when we see a demand for compute, that's when we actually deploy the resources. For some job schedulers, we do support the deallocation of VMs instead of full-on termination. And what that means is that you still kind of have control of that VM, but we're going to shut it down to save you money. And then when you're ready to use it again, Cycle Cloud just powers it back up. So you can think of it more of just like doing a suspend rather than a full delete of the resources. For the Cycle Cloud VM itself, there will be those resources do need to be deployed, but that'll be handled for you for the competition. Yes, we will get to the question about practice window and budget for that in just a minute. All right, if there's no other questions about the software or hardware side, so let's talk about the budgets. Oh, this slide didn't quite get updated from last year. So You won't, unlike previous years, we had kind of these testing windows leading up to the competition. We're just going to have one window this year. In practice, most teams really only took advantage of the last window. So we're just kind of simplifying things on our end and making it easier to manage. And we're just going to have one testing window similar to Oracle. You will have a budget for the testing period. That exact budget will be announced when we get a little bit closer to the testing period, but it won't be as large as the competition budget. It's meant to kind of act as a guideline for you to try and figure out, what hardware does my workload really benefit from? Let me make sure that I can get my software stack in place and working for the competition. But it won't be, you will have access to more budget for the competition itself. The bottom couple bullet points, when you get access to your CycleCloud installs, CycleCloud itself does have pricing information when you go to select the VMs that you want to deploy in your cluster. This is extremely useful if you're just kind of getting started and exploring and trying to figure out, okay, I know that I need VMs with 60 cores, or I know that I need VMs with these particular constraints. Which one's going to be the cheapest, both for the whole VM, but also what's cheapest per core? Some of these VM types, if you can see, it's kind of hard to see in this screenshot, but the price per core, or the total price of an HB120 VM is higher than an HB60, but the price per core is less than that because it has way more cores. It has a lot more memory bandwidth. So the CycleCloud pricing page is really useful for seeing that granular broken down by VM type and kind of figuring out, okay, relative to other VMs, how much does this cost? When you're trying to figure out your run rates for the competition, the Azure pricing calculator can be really helpful because you can essentially pick from the different components in your cluster. So the head node and a mix of, maybe you've got GPU nodes and then some CPU only nodes. You can plug all of that into the calculator and it's going to tell you what that's going to cost you either per hour or however many hours you want to put in there. So that can be really, really helpful for forecasting what you might be able to do during the competition. The other nice thing in CycleCloud is you do get essentially a cost forecast down here. When you get access to your testing environments and during the competition as well, you will also have access to a few API endpoints that will tell you your total spend for the window that we have selected. So both the testing window, and then when the competition starts, we'll reset that to calculate from the beginning of the competition. But the other nice thing that the API endpoint will tell you is your current burn rate. And that's what is this costing me per minute or per hour right now. So that can be really, really helpful, especially in the testing window if you're not exactly sure what the selection you've picked is going to cost you. It's also useful using the API endpoints because in CycleCloud, you can see that breakdown per cluster, but there's no way to see like what has all of this cost me together. But the API endpoint that you'll have access to will tell you the total cost that you've spent so far. Again, once we get closer to the testing window, I'll send those instructions on how to access those endpoints. Similar to previous years, instead of getting access to the Azure portal, each team is going to get login information to a dedicated CycleCloud install. That's also going to act as kind of your gateway into Azure, both for the testing window and for the competition. Actually, for the competition itself, this is going to be a little bit different for teams that are on-site versus the teams that are virtual. If you are virtual, you will only have access to your clusters through the Bastion VM. If you are on-site, you will have access to your clusters from anything that's on your competition subnet. So the network that your cluster is plugged into, you can log into this to your any of your clusters on Azure. I highly, highly, highly recommend. In fact, I may even disable this via policy this year. Please do not enable public IPs or password logins on your clusters themselves. We disable those for a reason. The Azure IP space is a prime target for hackers. And we have had in the past, pretty much every year, at least one team disregards this guidance and they end up with a compromised cluster. So please don't enable public IPs. And if you can avoid it, don't enable password logins on your clusters themselves. Use SSH public keys. It's going to be the safest way for you to do that. Your clusters will be restricted to a single resource group in Azure. So for anybody who is more familiar with the Azure ecosystem that may be relevant to you, for the purposes of the competition, this is really just for us to kind of keep an eye on things and make sure that teams aren't trying to skirt around the rules. The VM family quotas will be set ahead of the competition. There will be enough quota for everybody to use them. The quotas and number of VMs that teams will have access to is going to be kind of predetermined this year. Every year this comes up and we have teams that basically squat on a bunch of resources so that other teams can't access them. So this year we're kind of limiting the total quota and the VM selection type just to make it a little bit easier for us to manage and make it fair for everyone. I believe the note that Steve sent out for your architecture proposals included essentially the target quota that we're proposing for the competition. If there's a VM type in there that you don't see that you really want access to, please reach out to me via Discourse and we can discuss it there. Starting probably late next week, your advisors will get the login information to your test environment. You won't be able to log in or spin anything up yet until the test window starts. Right now, we're targeting October 24th through the 30th is going to be your testing window. So any questions about the access or budgets or quota? Again, the actual budget for the testing window will be announced when we get a little bit closer to that date. Are we allowed to mix and match VM types? Absolutely. In fact, you are encouraged to do so. That's kind of where the quotas that I've listed there were spec'd out, with the expectation that teams will probably want to mix and match those. And CycleCloud does allow for that either inside of one cluster, or if you wanted to deploy separate dedicated clusters, maybe you want one cluster that's dedicated to app A and you want a different cluster that's dedicated to app B. So yes, you can mix and match those. That's also sort of the reason why we continue to use CycleCloud and allow teams to pick which resources they want instead of prescribing it, because it is another decision for you guys to make, not necessarily for us to make. So it's similar to kind of when you had to spec out what the cluster you're bringing to the competition is going to look like. Okay, so every year we get this question, well, why are we using CycleCloud? Can I just log into the portal? I'm used to using XYZ tool. This just kind of helps answer a lot of those questions ahead of time. It just makes it easier for us to set up, manage the environments, and keep an eye on things. It also makes it honestly a lot easier for teams to get started and makes it a little bit more of a level playing field instead of having to learn all of the deep down, ways of how do you connect storage and VMs and set up your job scheduler and all of that in Azure. You have a pretty easy to use UI and template syntax to do that. One thing that I will mention, if your team does not currently use a job scheduler or you're not used to using a job scheduler, there are options in CycleCloud to deploy clusters without a job scheduler. The main thing there is that you won't get some of the auto scaling capabilities. You can still add and remove VMs, spin them up, shut them down, but you won't get some of that auto scale flexibility there. But you can choose to go without a scheduler. And then it also gives us more real-time cost reporting. Like I said, we can essentially calculate down to the minute what you've spent. I'll cover a little bit more on that as we get closer to the competition. It is based off of a 15-minute sliding window. And so when you shut everything down, it will look like your cluster is still spending money. That will get adjusted when the sliding window actually slides over and CycleCloud redoes the calculation. There are, I'm going to update this slide before we send it out too. There's a couple good resources for getting started that are probably a good read ahead of time. And you can also, if teams want to, you can sign up for, I think it's, Laura, do you remember what the student credit is on Azure? Is it $200?
I think it's 200, but let me check that.
Okay, so you can, we'll include a link to where you can get access to student credits as well, and sign up there. You'll have to do your own CycleCloud deployment, but it is kind of an easy way to go and play around and kick the tires. I will warn you, you will not have access to the HPC VM types when you use your student credit. It's something that they cost too much for it to be useful at that price point. And so you'll really only be able to spin up some of the more general purpose VM types. But here's a link to the CycleCloud documentation. The other really useful resource that I'll put a link to in here is we have a series of Microsoft Learn modules that are focused on our HPC hardware and software offerings. And they do include tutorials and walkthroughs on deploying CycleCloud, spinning clusters up and down with CycleCloud, and customizing those clusters. So that's a really great kind of walkthrough type view rather than having to go read through all of our docs to figure out how some of those pieces work. And then I'll also, like I said at the beginning of the webinar, I will include a link to the recording of last year's kind of deeper dive CycleCloud session.
And I've just posted a link in the chat there, Andy. As far as I can see, it's $100. But yeah, okay, we can check that.
Thanks, Laura. All right, so that's all that we have for the slides and prepared presentation. But at this point, if you have any questions, please feel free to either ask in chat or come off mute.
Looks like you covered everything pretty well then.
That's what I like to hear.
And Andy, just to confirm, the login information will be sent out mid-October, so in the next week or so, I'm guessing.
Yep, yeah, it will be probably mid to late next week, so before the testing window starts. That'll just allow people a chance to make sure that they can log in.
Mm-hmm. And if there are any issues with that, or if the logins don't come through, God forbid, who do we reach out to? Who do?
So if the logins don't come through, they can reach out to us via Discourse. They should come through, because I think Steve will yell at me if they don't. And if your team advisor is not getting the login information when we send the announcement that they've been sent out, please feel free to reach out via Discourse or reply to that email, and we'll see where it was actually sent. Similarly, if you've got login issues, feel free to reply to the email specific to your team. But otherwise, any other questions around using CycleCloud or what you'll have access to during the competition, all of those questions should go in Discourse. Yeah, that's correct. If teams want to go and sign up for a student account and use their $100 credit on practicing outside of the scheduled testing window, that's absolutely fine. I just wanted to make everyone aware that that is available. Obviously, there's nothing we can really do to prevent you from doing that anyway. So. I just want to make everyone aware.
Okay. Thanks, Andy and Laura. That was also really good information there.